Good afternoon, everybody. I hope you're having a wonderful jam. I'm Rob Williams. This is Simon. Thank you very much for coming to this session. I hope you get something out of it. I'm trying to work through by solving real-world problems, and Simon's got a great demonstration of how he solves a real-world problem. Do you want to say hi?
Yeah. I'm Simon. I'm working for i67, a BlackBerry partner in Germany. And we just ported one of our major business applications to BlackBerry 10. And there was a lot of data storage to be solved there. We have a caching and offline solution, mainly using SQLite.
Okay, great. So, as I mentioned already, we do want to help you solve some problems, or at least give you some ideas on what you have to tackle. I'm going to talk about a lot of things, maybe a little bit preachy-like, but hopefully you get something to take home and build a better app, a better user experience, integrated beautifully with BlackBerry 10. So I'm going to talk about what I'm going to try and work with, which is a very light version of what Simon's working with. I'm going to talk about how I tried to solve it using web, and Simon's going to use native, and then we'll open up for a question period if anyone's got some questions. Okay, the problem I'm going to try and solve is a traveling salesperson problem. So it's customer relationship management. Now, your agents, they need to be out in the field. They need access to those confidential customer records. They need access as well if their device goes offline, as anyone connected to the Wi-Fi at the conference might be experiencing. Yeah, okay, it has to be at their fingertips, and also, any changes they make, any reports they add, they need to be reported back to the server. Okay, thin and thick clients are ideal for displaying data in the cloud. Unfortunately, when the cloud goes away, thin clients are useless. Thicker clients can still be useful in some regards, depending on how they're implemented. And the solution to this is data storage. Unfortunately, just saying data storage solves a problem is dismissing how big the problem is. This is a really complex problem, and it is really hard to do right. And if you do it right, you're going to have the best experience, and you'll have the best apps. First issue is that the data in the cloud is big. So depending on your system, you might have servers with terabytes or zettabytes of storage. An incredible amount of data that's sitting there at someone who's online's fingertips constantly. BlackBerry smartphones have gigabytes of storage. So you cannot just get all of your data. There's a blank point there. Interesting. The data must have been secret. Okay, the data in the cloud is really, really complex. So for all the possible queries you could run, for all of the possible relationships that could be invisible or expressed implicitly, explicitly inside that data, how are you going to track them? There might be many multimedia assets in the cloud. So there are some videos for people, presentations, Excel spreadsheets, lots and lots of resources. The number of queries that you can run against a huge data set is huge, and the number of return results is huge as well. So, got to keep thinking about that. Next thing, queries that run in the cloud have far, far more horsepower. So you might have, inside your enterprise, you might have 27 full-time DBAs and sysadmins that are going to turn on a new VM cluster. So all of a sudden the queries start running faster. If you're trying to do that query in JavaScript on your BlackBerry smartphone, it will probably run slower. Probably. Oh, synchronization. So when that agent does come back online and she submits her additions, how do you synchronize? It, again, is complex. If people have updated the same records, there's contention issues to deal with. So it's non-trivial. Then you might also have some protection requirements to your data. Data in transit may require encryption. Now, SSL can take care of that, but can you guarantee what SSL algorithm, TLS algorithm you're using? Does that meet your bank's requirements? Ooh. You okay?
Yes.
Oh, that's good. For the record, someone just fell over. Okay. Data at rest may require encryption too. So if there are policies, you're going to have to somehow encrypt that. And encrypting from JavaScript is also not trivial. There are open source plugins for lots of good algorithms, but they aren't as efficient as other ways. Cleaning. If your enterprise has demanded a purge of data that you're storing on that device, when someone goes rogue, how are you going to get rid of it? And I think that's a really hard problem. So they go rogue, so they take their phone and they put it into a Faraday cage. So it's never going to get another radio signal in its life. And they just stick their hands in and look at the data forever. You can't send a message to that. If you are looking at the clock and you haven't phoned home, then you run into the problem of, oh, have they not phoned home because they're still in the mountains? Or have they not phoned home because they're bad? Let's nuke their data anyway. Yeah, it's not an easy problem to solve gracefully. So let's talk about choosing some strategies and some of the HTML5 storage systems that we have available to us and what I chose to do. Local storage. Local storage is very, very easy to use. If you have looked online at some of the presentations from JAM Asia, you will see there's a slide talking about local storage that says easy about 7 times, and the next slide mentions, did I mention it was easy? So yeah, it's pretty easy. It's just a dictionary or a map of string values. So if you use JSON or some other serialization technique, you can put objects into local storage and get them back later. If you are a Java programmer or a Qt programmer, it's similar to a QMap or a hash map. Now, it is really, really good for sticking small or few things in. So if you're sticking something that is really, really big in there, your pages are going to become less responsive because every part of that data is always available. It's not loaded on demand, it is always there. It is bad for storing big or many things, and like I just said, fully available with each page. So, WebSQL. WebSQL, unfortunately, got rejected as a standard. It is deprecated now, and it's not going to be part of HTML5. But yes, we do support it. And then in Puppet voice, but I love WebSQL. Yes, it's there. We support it. You can use it. And just about everything I'm going to say about indexDB coming up equally applies to WebSQL. Now, indexDB is a really versatile foundation to solving your offline data problems. It lets you store keys and value pairs in multiple object stores. So if you have certain types of objects, you put them in their own store. Now, if you are used to relational databases, this is not one. You can't have foreign keys. There's no remote object lookup. But the objects that you store can be arbitrarily complex. So you could store an entire relationship in one object store. So you could have, and this is what I've actually done in my demo, is for the customer, all of the contacts that that customer has could be stored in the same object. So in my case, I've done it that there is a contacts array, and so that's another array of objects. Something really cool about indexDB is it lets you store pretty much any JavaScript expression. So you can store functions as entries in the database, dates, numbers. Something that is really, really good for when you are trying to get your data back out is the ability to create indexes. Now, the indexes are a little bit primitive. I'm going to talk about that in a second. But if you know how you're going to be searching your data, creating an index is far superior to getting all the records and searching for the 5th one that you want. It's also transactional, so you can abort, which is very, very important. Now, I said we're going to talk about building solutions. Saying it's just a foundation isn't really a solution. It's just somewhere to start. IndexDB is dumb. If you give it an object to stick in the IndexDB, the object will stick in the IndexDB. The smart thing is you guys, is the developers. You've got to make decisions that make your app run well. So if you are selecting good indexes, your application is going to run faster. And like I mentioned, iterating through the objects that have come back is not going to lead to good performance. Significant thought should be put into them. I'm going to jump ahead a bit here. One of the things that IndexDB indexes don't support is multilingual sorting. So if you have foreign languages, or well, that's a bit inappropriate, if you have non-English languages that you want to be sorting correctly, then you're going to have to do that yourself by creating an index on something else. Now, it sounds like a bit of work, but for you to go through and convert, say, the names to a secondary representation that takes each character, translates it to a number where the sort order is relevant, and store that number as an element in your object, then you've done a little bit of work. You've taken up a little bit more storage space, but you're going to have faster performance at query time. Because instead of getting them all out in English sorting and then sorting them yourself again in JavaScript, the index will do it for you faster. Now, something is really good at these objects and stores. They are very, very easy to use, totally self-contained. If you have 27 object stores, they are independent. So stuff that you do to one doesn't touch the others at all. And again, if you're used to relational databases and foreign keys, no foreign keys, nothing like that. Problem here is you might be sacrificing some convenience for a lot of wasted space, because it's easy to forget normalization. I mentioned that in my data set, I have my customers, and all the contacts inside that customer are built in to the one object. Now, if there was someone who worked for two companies, they would be appearing under two different customers. So because I've chosen a tree model where each object is independent, I have no way to easily find those other contacts and change their data. I hope everyone put their phones on vibrate before they came in. I'm just going to turn mine on to vibrate. Can you turn that off? That's embarrassing. Now, it's a lot easier to code if you just have the data you need exactly where you need it. Of course, in my case, I just look in there. There's the contacts array. Look at contact number 2. Fantastic. Let's give them a call. Now, very easy to code, but are you running into normalization issues? Possibly. I don't know your data space, so it's up to you. Now, something that you do have to be aware of is redundancies. If you are filling up object stores with those objects, are you accidentally putting in duplicates? Now, indexDB only checks the key. When you create an object store, you say what the key is. So if you are not managing and creating a practical primary key for your records and reinserting stuff, you're going to have lots of duplicates and you're going to be wasting space. IndexDB, when you try and do an add for something that is already there with the same key, it just does a replace. If you're just adding and you haven't made your keys coherent, you're going to have trouble. Now, generally, there's going to be a business analyst that spent a very long time, or a team of business analysts, or similar positions, that spent a long time designing your database. They maybe should have some say in what happens client side. Some pitfalls. No text search. So if you're used to running a SQL where something is like something else, or other more advanced text searches, then you're going to have to rethink the problem if you use indexDB. Anyone got any suggestions? It's tricky. No multilingual sorting, I already mentioned that. And absolutely no synchronization features. It is transactional, so your transactions which are local are maintained, but there is nothing at all to make sure that you are transactionally correct or synchronized against a remote database. Okay. Ooh, there is no API to know how big your database is. I find that really surprising. Under Chrome, if you're running under Chrome using indexDB, you get something like 5 megabytes of storage before Chrome says to the user, are you sure that this app should get more storage? And they can say no. So you have no idea that you're about to hit that 5 meg, and all of a sudden you can't allocate more space. So in preparing for this, I tried to write some test code to see how much data I could shove into Chrome. I had a huge transaction that had something like 40 or 50,000 objects that were each 40 or 50K getting inserted, and Chrome crashed. So I can't tell you how to tell, because when I tried to test it by brute force, it failed. Counting is really slow. Just knowing how many records you have, if you aren't doing that yourself independently, and that leads to data redundancy, then when you actually want to know exactly how many records you have, there's a performance hit. It is slow. Now, being asynchronous, that isn't a pitfall. That's actually a really good feature because you can ask the database to do stuff, ask the database to find records, and you can get back to reality and keep doing other stuff. Trouble is your UI has to indicate that it is asynchronous. If someone has hit that search button and nothing happens, the button hasn't grayed out, they're going to press it again. And the way it works is you get independent transactions in independent threads, all behind the scenes, and a little bit later they're going to have pressed the button 6 times. And then they get 6 different results because your transaction was adding money to their bank account. So being asynchronous is fantastic for fluid performance, but if you don't build your UI right, it's horrible. Something else that really frustrated me building my demo, Google Chrome has a different, newer implementation. So if you are used to building your HTML5 app and testing it in Ripple, the way that you create object stores and update the database inside Chrome is newer and does not work on BlackBerry 10 at this time. What was the other thing I found? Oh yeah, when you do create it, if you create it using the API that isn't supported yet or the old API, and you try and use the new API, you could never modify the schema again. So I tried just to run BlackBerry 10 code on Chrome because it is backwards compatible, but I'd previously created my database using the newer API, and I couldn't touch my data. So I don't think that's intentional. It's just a pitfall I discovered trying to build a practical solution. So let's try and tie this back to my problem description from the start. Okay, indexDB, it's dumb. It's for CRUD. Create, read, update, delete. What makes it powerful is you and how you choose to represent your data model, how you choose to represent your assets and how you store them. And for big data, it's you that has to know how to prune the tree or prune the graph. Like if you are inserting every single asset you have, every single connection you have, then you're wasting bandwidth. Is the user ever going to query that sort of stuff? Probably not. You have to also choose where that trimming is done. If it is all done on the server side, then you're probably going to get more performance. But is it going to be harder to deploy? Is it going to be easy to make it correct for your BlackBerry 10 device? If it's the client that is trimming the data, bandwidth problems. Are you sending far too much to that client for it to say, you know, I only needed 3 of those records? All choices that you have to make. You also have to make sure you know what is suitable and how to present what is suitable to your users. Like, if it's worth keeping, keep it, but you have to be smart and make those decisions. So is this actually helping solve a problem and getting you thinking, or am I just making things sound too hard? Uh-oh. Okay. Now, something else that is really cool in WebWorks is direct file access. So inside JavaScript code, you can read and write files. So some content from the server might be more appropriately stored on the file system. So if one of the assets you're fetching, because this customer you're going to is a demo video, putting that in indexDB is silly. Putting it in local storage is ridiculously silly. So here, you can write it to the file system. And something that is fantastic is from WebWorks, you can write files to the SD card. I think that's a big deal, because I've been a web developer on and off for many years, and JavaScript being able to do that is really neat. I think it's really cool. I've got consumer in brackets there. If you are writing an enterprise application that is deployed from the enterprise BlackBerry world, you cannot write to the SD card. That's off limits. So that's worth keeping in mind. So suddenly, your storage capacity has gone from, oh, maybe it's just 5 meg for my database, up to 64 gig. I think 64 gig is the biggest SD card that we handle. That's quite the increase. Protection. Like I mentioned at the start, that you might have requirements for protecting your data. You do have the platform protections. Now the database is of course only accessible by your application. However, there is Web Inspector. If you've done something like left debug on, then anyone can connect at any time and look at every single object in your object store. There is a warning when you start an app that Web Inspector is on, but if users have gotten into the mode of always dismissing that annoying dialogue, are you going to know? You do have the file system protections. So we have the sandboxing of different user accounts and different application spaces so that only your application can access those files. You also do have the option to encrypt the entire SD card. Now the problem with encrypting it is if someone steals the SD card, they're not going to be able to read it. But if the whole point of putting assets on the SD card was so that when you arrived, you could give someone the SD card and they could put it straight into their printer, suddenly their printer can't read it. So for the protections, you've got to make good decisions. So for in transit, what do you need on top of TLS? So do you have client certificate requirements? So I think right now in WebWorks, there's no way for you to say XML HTTP request and specify a client certificate. So if your data needs to be client certificate protected when en route, how are you going to do that? Extensions. Okay, at rest, I would also recommend a native extension, and again, for performance reasons. The pure JavaScript crypto libraries are fantastically written, highly optimized, but the native C crypto library is also well written and highly optimized and not interpreted. And then, once you start messing with encryption, you have the chicken and the egg problem of where do the keys live? So if you're doing symmetrical keys, maybe they're generated from a password. If you're doing asymmetrical keys, who generates them? Where do you store them? How do you recover them? What's your strategy there? Data storage is really complex, but really fun. So now, I'm going to try and do a quick demo on my little phone that keeps on going ba-ding. Okay, so to quickly describe what I have running, oh look, Web Inspector's enabled. I'll just dismiss that annoying dialogue. So what I have running here is I do have a collection of customers and the contact for those customers that I'm viewing. Now, I am connected to this laptop, and this laptop right now is a web server. So it is the data source that is going to be fetched by my application. Now, if I purge everything, I see absolutely nothing. If I go to fetch data, it sends a query off, and because this is a demo, absolutely nothing happens. Oh, that's not right. Oh, look. Oh, dear. Well, the problem is it's not plugged in because this dangly cable was going down to the floor. probably work much better in 5 seconds. Come on, USB. Let's try that again. I think we did just prove that the offline part works. Kind of. Okay, so let's fetch data. Oh, good. This time we have a list of all the agents. Because if you are traveling together, it might be useful for you to have your 3 colleagues as data as well. So I'm just going to go in and I'm going to say that I'm this person. And here are all the customers that are on my web server in the cloud that I deal with. These are not customers I don't deal with. The customers that are in the database is much larger than that. So I can say I want to get the data from those 3 customers, and I'd want to synchronize. And it does say the customer data was pulled from the server. And we can see it on the screen. Let's unplug USB again so I no longer have that network connection to my laptop. So I do still see all of my data. Now what I want to show you is what's in the indexed database at this time. So I'm going to quickly unlock this computer, show you what's going on. So here's the Web Inspector view. I can see all of the assets and resources owned by this app because it is a WebWorks app. If I go into resources, I can see that JAM345 has 1 indexDB object store, and it is 3 customers. However, we do see here in the list that for each customer, I have multiple contacts. So I have Tamika Deshner, the VP of photobombing, and I have Boyd, the VP of customization. So they are all there, but I did mention that I was going to store everything self-contained inside a tree. So if I go over and expand on one of these objects, I mentioned that there's a contacts array, and here are all the self-contained objects. Something else I mentioned that's really nice is the ability to store files. So I'm going to, excuse me, start the file manager and have a look on the SD card. So right now you'll see that there is no very badly drawn image in the root of my SD card. Switch back over here to the app, press my SD test button, and it says the file was copied. So what I did just then was I sent a request to the web server to give me a certain asset. It sent it back, and it was in binary because this is an image file, and I wrote it directly to the SD card, which we can now see. So I feel to some degree I have talked about how hard the problem is and then solved a very trivial version of it, but it's a foundation. And my intent here is to get you thinking about how you're going to make your apps better by adding that offline storage component to them. The whole fact that you can write files and get those assets down, I really do like that. So if you were collecting videos or spreadsheets, you could have copied them down as well. And now you can just click them on the SD card and the customer can view them. And I think it's now over to Simon.
Where's your clicker thing?
That's a good question. Of course it's on the floor.
That's your demonstration, I guess.
Yes. It's upside down.
Ah.
Sorry.
Okay, so for our application, we have one of the thin clients mentioned by Rob before. So actually, all our UI and data comes from the server using a SOAP web service from SAP backends. And to add offline capacity to our application, we created a persistence layer and stored basically all the objects we got from the web service in SQLite. And we have also an implementation for full offline working, but that will come a bit later, so I'm not able to show it now in BB10. So basically, to set up SQL, you need to modify the profile. And then we have created a service for all this persistence work and published it to QML to be able to use it there. So by calling setContextProperty, the QML knows about it, and you can use it from your UI. Then you create a database. So this is called CacheDB, very simple, and then create a lot of tables if they don't exist. So if you start the application for the first time, the whole database is initialized, otherwise all this is skipped. Then you can read results with query next, and usually I just go by index and select the first value, second value, and so on. To handle an error, you check if the query is active, and we usually just print out a warning to QWarning to see it in the console, and log it into the log file. To build a statement, you can either use QString with arguments, which is very convenient, or QSQL query with bind values to prepare it. And to receive a unique object from the database, we use hash functions, and QHash is a Qt class with a free function QHash, where you can get hash codes from most basic classes. And we have implemented the hash code function in most of our more complex classes to get a unique key for that. Now to access this all from QML, you need the QInvocable macro. And so this getLicenseDate, for example, it's callable directly from QML, and you just use it by persistence service, getLicenseDate, and persistence service is the name we used before to register the service. And we found a lot of performance improvements that were possible using the Q database. So at the beginning, we used SQL data access, which is a Cascades class. And by switching to QSQL query, we had a performance improvement about the factor 10. And then we found some other things. For example, this set forward only is an option on QSQL query. And usually, you just iterate through the result in one direction forward. And then it gets really faster as well. Our configuration and things like the license state, they are loaded at the startup of the application to keep them transient, because SQL is fast, but memory is much faster. And before we try to load any large objects, we check if they exist at all. And most of the SQL is not is synchronous from the start, so we use threads for complex operations to not block the UI. So this is a sample of a thread, but as I have learned here on a previous session, there are some simpler solutions with Qt concurrent. So maybe we will rework that later. And yeah.
Did you go 2 slides then?
Sorry?
Oh, I thought you went 2 slides.
No. So what's very important for me as a Java developer, just went over to C++, is the memory management. And if you persist objects to a database and read them later on, you're always creating new objects, and it's very important to clean up later. And QObject has a tree model where you can set the parent to an object, and later on you just have to delete the topmost object, and everything else, the whole tree, is then deleted afterwards. And to improve that, you can use smart pointers, and they will do the work for you, basically. Then we have a time to live for all cache values, so that we don't get very old content from our cache. And yeah, one of the tricks we learned here is if you want to signal from the native layer to the QML, you can send a QObject pointer instead of the real class type, and then it works. So let's see, I can show you a demo. So this is our application. The icons and text and so on, they are all retrieved from the server. And yeah, the network here is not so very good, so I've cached a few things. When I click on a page, it's now loaded from cache, so you can see there it's from yesterday evening. Now I'm looking up a customer in the SAP database. And click on it to see the details. And so you can see yesterday evening I loaded all these data in my hotel room with a good Wi-Fi to get access to them. And yeah, we can now try to refresh it from the network. So it worked, but you can see it's a lot slower, and now from cache is from today, at this time. Yeah, then we have attachments when they are then saved on the SD card or in device memory, so similar to the web SQL. And yeah, then I can show a quick code sample from this laptop, I think. Yeah. So we don't store objects directly, but serialize them with each attribute. So we get a very long SQL query, and then create an object. And you can see here is the parent. The configuration is the parent. So afterwards, when we delete the configuration, all this stuff that we load here is all thrown away.
Upside down.
Oh yeah, upside down again.
Okay, one thing that you can't forget is balance, BlackBerry balance, and the perimeters. Now, if you are hitting a back-end database from a consumer, from your play area, then you can use pretty much any port you want. We're talking TCP ports. So if you have written an app and you've included an Oracle driver and you are hitting an Oracle database on Oracle's custom port, then your consumer app is going to run perfectly. When you make the switch over to it being an enterprise app though, and it is inside the work perimeter, then you get HTTP and HTTPS in and out, well, out. So all of a sudden, you're not going to be able to make a connection. Something you've got to be aware of. I already mentioned that there is the difference in you get no access to the SD card. When you are an enterprise app, you will also have totally independent shared files. So if someone has their work perimeter locked, they're in their personal perimeter, they take tons of product photos, that's going to be fine. If you have a personal app and they took the photos when they were in their enterprise perimeter, then they can never access them for you to upload, because they're all put into the shared camera directory inside the enterprise perimeter, and you can't touch it. So writing an app that uses data storage locally, you have to consider a lot of things. You have to consider what you're going to store. You have to consider how you're going to cache what you store to make it easily accessible again later. You have to consider where to store it. You may have to consider, are you going to encrypt what you store? Lots of things to think about. Now, if there are any questions, love to take them. If people would love to follow up, sometimes there's a surprise slide. So if you'd like to follow up privately, that is fantastic as well. My Twitter address is at Robbie W, D-U-B-Y-A.
Simon Hain.
That's an easy one. So yeah, you can come up and talk to us now or do loud questions. Do we have any questions from the room? Yeah. Just wait for the mic for 1 second.
I would like to know some specification about cases when we cannot have file access. Because I know that we can't access file from WebWorks when we include some partials, or when we put something after the path, some kind of arguments. And I would love to know if there are any other...
So are you specifically addressing local files?
Local files,
yeah.
Yes.
Yeah, you are sandboxed, just like a native application is.
It's not a problem about sandbox, because sandbox file system and unsandboxed file system isn't accessible when I include some partials.
Okay. Did you have the requested permission in config XML?
Yes, I did. It all works if there are no includes. And I'm not the only person who had this problem.
That sounds really frustrating.
Yes, it is.
Offhand, I can't think of anything else, but let's take a look at this offline.
Right now?
Well, after the session.
Okay, thank you.
Okay. So any questions that I might be able to answer?
Completely done.
Okay, so now that I'm looking at the surprise slide, oh, sorry, we do have a question.
So you mentioned encryption. If we're storing in the work perimeter from either of the mechanisms you were talking about, do you get encryption for free?
You do. The file systems are encrypted. But if you're storing that file in a shared space, then any other application inside the work perimeter sees it in that shared space as plain text. It can open it and read it. If someone was to steal the device and look at the flash memory, they will see an encrypted file, but other applications could be reading that. So if you had a requirement to put it in the shared system, but not be readable by anybody else, then you would have to independently encrypt on top of the encrypted file system. Don't forget to download the conference guide, given that the last sessions of the day are almost over. But seriously, do complete the session surveys, because it is really important for us to hear the feedback so that we can make sure that this conference is the best experience it can be. So if it was too technical...
The next time.
Oh, the next time, yeah. So if it was too technical, say so. If you wanted more hands-on, say so. All of your feedback is appreciated. And thank you very, very much for attending BlackBerry Jam Europe.